In the stillness of deep space, silence reigns absolute. No wind whispers, no waves break, no breath stirs. It is an endless desert of stars and shadows, where light itself takes eons to cross the distance. Here, in this abyss beyond imagination, the universe hides its most secret reservoirs, not of planets, but of the cosmos itself. In 2011, astronomers using the Plateau de Buer interferometer and NASA's Spitzer space telescope revealed a discovery so immense it reshaped the way humanity thinks about the universe. Billions of light years away, orbiting a quasar in the early cosmos, they found a colossal cloud of water, vapor so vast it contained 140 trillion times the water found in all of Earth's oceans combined. An ocean of vapor adrift in the void, stretched across light years, invisible yet undeniably real. It is the largest and oldest known reservoir of water in existence. Born when the universe itself was still young, water on Earth, it trickles from glaciers, flows in rivers, and sustains every living cell. It is the quiet architect of biology, the hidden script of evolution. Its molecular dance has written the story of every creature that ever walked, swam, or breathed. And yet, in the frozen silence of intergalactic space, it exists in a form untouched by life, a reminder that this substance is not Earth's alone. It is a universal ingredient, scattered like whispers through the cosmos. But what does it mean that water, the elixir of life, exists in such unthinkable abundance, so far from home? Is this discovery a silent witness to the birth of galaxies, carried like ancient memory from the earliest epochs of creation? Or does it hint at a deeper truth, that the universe itself may be seeded with the very elements that once stirred the spark of life on Earth? This water does not cascade in rivers or glisten on lakes. It drifts in a molecular mist, heated by the energy of a ravenous black hole at the quasar's heart. It is not water as we know it, but a cosmic phantom, a trace of something timeless. And yet, in its presence, we are forced to ask a question as old as humanity's gaze at the stars. If the essence of life is scattered through the void, does it mean that life itself is not rare, but inevitable? The desert of space, once thought barren, now shimmers with the faint echo of oceans. Somewhere in the silence, the universe whispers its first secret, that the ingredients of life may be written not only into the soil of planets, but into the fabric of the cosmos itself. The search for cosmic water began not in oceans, but in silence, listening to the faintest tremors of the universe. Astronomers knew that some of the brightest lighthouses in the cosmos were quasars, blazing hearts of distant galaxies, where supermassive black holes devour matter and unleash torrents of energy that outshine entire constellations. These beacons, though violent, serve as natural lanterns, illuminating the fog of the early universe. And within that light, hidden in radio frequencies too faint for human senses, whispered the signatures of molecules that should not have been there. One such beacon, a quasar named APM 082, lay more than 12 billion light-years away. Its light began its journey when the cosmos was less than 2 billion years old, carrying with it not just the story of a single galaxy, but the chemistry of a universe still in its adolescence. Around this quasar, astronomers suspected something extraordinary, reservoir of water vapor so immense it defied imagination. The suspicion began with delicate hints, radio signals distorted by time and distance, nearly drowned in the background noise of the cosmos. Detecting them was like hearing the faint echo of a drop of rain in the middle of a storm. To uncover the truth, astronomers turned to some of the most precise instruments ever built, the IRM Plateau de Buer interferometer in the French Alps and NASA's Herschel space observatory orbiting far above Earth's atmosphere. Together, They could sift through cosmic static, disentangling the faint fingerprints of molecules from the roar of quasars. Water, when warmed amidst radiation at specific frequencies, a molecular whisper distinct enough to be recognized even across billions of light years. By tuning their instruments to these frequencies, scientists began to isolate the unmistakable signal of HO vapor drifting in colossal clouds around the quasar. The detection was not immediate. It was the culmination of countless nights, where researchers traced patterns of energy, recalibrated for distortions, and repeated calculations until certainty emerged. Each faint trace confirmed that what they had found was really a water cloud larger than any seen before, held in the gravitational grip of a black hole consuming matter at unimaginable rates. In the dim control rooms of observatories, the discovery carried with it a quiet weight. Scientists stared at data that revealed water not as a rare terrestrial blessing, but as a universal presence. It was as though the universe had spoken in its softest voice, and against all odds, humanity had learned how to listen. The vast vapor cloud around a PM082 became more than a scientific finding. It was a revelation, a reminder that the molecules essential to life were not confined to Earth, nor even to nearby planets, but woven into the earliest fabric of galaxies. Each signal etched into the instruments was a message from the deep past, proof that even when the cosmos was young and turbulent, water was already flowing through its veins, that reshaped the imagination of astronomy. This was not a frozen remnant of a dying system, nor a fleeting trace clinging to a planetary atmosphere. It was a sprawling ocean in vapor form, orbiting within the gravitational sphere of a supermassive black hole. And it told a deeper story about what the cosmos had been capable of long before. Earth had cooled from fire into stone. The quasar itself was a furnace, its black hole devouring matter at a rate that transformed mass into torrents of light and radiation. This violent heart heated the surrounding gas to millions of degrees, creating conditions under which molecules like water vapor could persist and shine with their subtle but undeniable signals. Astronomers, decoding those signals, realized that the sheer abundance of water there was staggering. It was not merely present, it was prolific, a cosmic ocean suspended in mist. The implications were profound. If water could accumulate in such massive quantities so early in the universe's history, then its presence elsewhere, in countless other galaxies, might be more common than once imagined. Yet measuring such a phenomenon was no simple act. Every photon captured had traveled across more than 12 billion years of cosmic expansion. Its wavelength stretched, its energy diluted. Instruments had to account for distortions from Earth's atmosphere, fluctuations in temperature, even the faint tremors of tectonic shifts beneath the observatories themselves. The process resembled archaeology, but on a universal scale, dusting away interference until the fossilized signature of water revealed itself. Behind these measurements stood human persistence. Nights of long exposure runs, of silent rooms lit only by monitors translating invisible frequencies into graphs and patterns, bore fruit in the quiet realization that they were witnessing something never before seen. There was a sense of standing on a shoreline, gazing not at an ocean of Earth, but at an ocean of the cosmos, billions of years and billions of light years away. It was a discovery that blurred the line between science and wonder. For the scientists who pieced it together, the knowledge carried more than academic value. It was a reminder that the universe, often described as cold and indifferent, still carried within its structure the very molecule that had given rise to life. It suggested continuity, a thread running from the earliest galaxies to the fragile biosphere of Earth. Water, it seemed, was not a local accident, but a universal refrain, echoing through time and space, The discovery of water around a PM 082 did not answer the ultimate question of life beyond Earth, but it sharpened the mystery. If such reservoirs existed when the universe was young, then the stage for life may have been set far earlier, and on a scale far greater than humanity had dared to imagine. It was not just water they had found. It was a possibility written across the stars in the faintest of signals, waiting for those who knew how to listen. When the results were first shared, the reaction within the astronomy community was a mixture of astonishment and disbelief. Water was expected in the universe, yes, but not in such an incomprehensible abundance. Astronomers had long assumed that water molecules formed in star-forming regions, in icy mantles on dust grains, or in the atmospheres of young planets. Yet here was evidence of a cosmic reservoir so vast that it dwarfed the combined oceans of every world known, real or imagined. The scale was not simply large, it was nearly beyond comprehension. Scientists struggled to communicate what 140 trillion times the water of Earth's oceans truly meant. Numbers of such magnitude collapse under their own weight, leaving language itself inadequate. Some compared it to oceans spanning galaxies. Others invoked metaphors of endless rivers pouring through the void. But each attempt seemed only to highlight the fragility of Earth's own seas, suddenly rendered provincial, mere droplets in a cosmic tide. At first, there were cautious whispers of doubt. Could the instruments have been misled? Could background noise, gravitational lensing, or calibration errors have conjured a signal that did not exist? For weeks and months, data was scrutinized, models recalculated, algorithms tested against every conceivable artifact. The extraordinary nature of the claim demanded extraordinary proof, and yet with each refinement the signal remained water, undeniable and immense, orbiting a quasar from the dawn of time. The media, however, needed no such caution. Headlines quickly spoke of the universe's largest ocean, painting images of cosmic seas shimmering in the darkness. The narrative leaped from journals to newspapers to television screens, transforming careful data into poetry for the public imagination. While the words captured wonder, they also simplified a truth more subtle. This was not liquid water pooling on planetary surfaces, but vapor spread thinly across interstellar scales. It was an ocean in name only, yet its grandeur was no less real. Among scientists, the response was quieter, tinged with awe. If such reservoirs could exist around a single quasar, then water might not be a rare jewel scattered sparingly across the universe, but a common thread woven into its fabric. The implications reached beyond astronomy into philosophy. Earth's oceans, once thought to embody the abundance of nature, now seemed fragile against the immensity of cosmic stores. The very element that carved valleys, nurtured forests, and sustained civilizations on Earth was revealed to be abundant in places where life itself may never touch. In that realization lay a paradox both humbling and hopeful. Humbling because it diminished humanity's sense of uniqueness. Hopeful because it whispered of universality, that the chemistry of life's beginnings was not confined to a single world. The universe, it seemed, had been carrying water in its earliest vaults, long before Earth drew its first clouds or seas, and in that knowledge, scientists glimpsed the faint possibility that life, too, might not be rare, but inevitable. The quiet corridors of observatories and universities carried a peculiar weight after the announcement. It was not the celebratory atmosphere of discovery alone, but the sobering sense of encountering something that stretched far beyond the reach of language or metaphor. To many, the sheer abundance of water in the early universe demanded a rewriting of expectations. It had been easy to imagine water as the exception, a fragile compound scattered sparingly among the stars. Now, it seemed, water was not only common, but foundational. A player in the drama of galaxies from their earliest acts. Peer review brought its own turbulence. Papers submitted to journals were dissected line by line, their assumptions interrogated, their models stress-tested against alternative interpretations. Some raised questions about the possibility of contamination from foreground galaxies, or whether gravitational lensing had magnified the reservoir into an illusion of immensity. Others countered with simulations, showing how the conditions near a quasar's accretion disk could indeed sustain such massive vapor clouds. The debate sharpened not into skepticism, but into rigor, a collective effort to ensure that the finding could withstand the weight of history. Meanwhile, in the wider world, the discovery spilled into culture in ways scientists could never fully control. For the public, the headline was simple: oceans in space. It captured imagination in a way few astronomical findings had since the detection of exoplanets. Artists painted visions of starfields reflected in endless seas. Poets wrote of cosmic tides, and philosophers quietly noted how small Earth's blue world seemed when measured against such immensity. The metaphor had escaped the journals, and with it came a shift in perspective. For researchers close to the data, awe mingled with unease. To stand before such scale was to confront the limits of human comprehension. The Earth, with all its civilizations, its histories, and its seas, became a fragile island, its oceans suddenly less infinite than they once appeared. The planet's waters, precious and finite, could be exhausted, polluted, or lost while in the cosmos. Water drifted in near inconceivable abundance, untouched and unreachable. The contrast was haunting, yet within that contrast lay a spark of possibility. If water could collect around quasars 12 billion years ago, then its presence was not a late development of cosmic evolution, but an ancient constant. It meant that the chemistry of life's most essential ingredient was not confined to a narrow window of time or space. Water had been there at the dawn of galaxies, carried in clouds that would one day seed stars and planets. Its story was older than Earth itself. Scientists who stared at those numbers did more than measure. They reflected, if water is written so deeply into the fabric of the universe, then the question is no longer whether life is possible beyond Earth, but whether it could ever have been avoided. The discovery was not an end, but an opening and invitation to reimagine the cosmos, not as barren, but as quietly fertile, waiting to be understood, long before the quasar's secret was unveiled. The search for cosmic water had already begun. In the 19th century, as spectroscopy emerged, scientists first learned to read the universe as a book of light. Each element and molecule left behind as signature dark lines etched into the spectrum like fingerprints imprinted on starlight. Through these faint codes, astronomers uncovered the chemistry of distant worlds, and among the earliest whispers was the unmistakable trace of water. The initial discoveries were close to home. Comets, wandering relics of the solar system's birth, revealed ice locked within their nuclei. When warmed by the sun, they exhaled vapor, a fleeting halo that betrayed the presence of frozen reservoirs older than Earth itself. Planetary atmospheres soon followed, water detected in the clouds of Mars, in the thick haze of Jupiter and Saturn, and in the geysers bursting from Enceladus and Europa. Each finding carried the same message: water was not a solitary gift to Earth, but a shared inheritance written into the architecture of worlds. As technology advanced, the search extended beyond the planets to the interstellar medium itself. Radio astronomy, still young in the mid-20th century, gave scientists the ability to detect molecules hidden in the dark lanes between stars. Among the first molecules ever identified in those vast clouds was water, its signal faint yet unmistakable, though measured in droplets compared to the quasar's torrent. These findings revealed a cosmos already seeded with life's most essential ingredient. The comparison between these early detections and the later revelation of a PM082 was staggering. Where comets carried water in frozen grains, and interstellar clouds held wisps measured in thousands of solar masses, the quasar reservoir expanded into trillions upon trillions. The scale shifted from the local to the cosmic, from drops to oceans. It was as though astronomers had spent decades studying puddles, only to discover that beyond the horizon lay an unseen sea-spanning galaxy. None of this progress unfolded in isolation. International collaborations became the lifeblood of discovery. Observatories in Chile, Spain, France, and Hawaii, spacecraft orbiting high above Earth's atmosphere, and computer clusters distributed across continents worked in concert. Data crossed borders as freely as starlight itself, pooled together to form a clearer picture of the universe's chemistry. Each nation contributed a fragment, and together they assembled a tapestry of cosmic water, drop by drop, spectrum by spectrum. Through these milestones, a new metaphor began to take shape. The universe itself appeared less like an empty void and more like a hidden ocean, its waters not confined to liquid seas but dispersed in vapor, ice, and cloud across the stars. Each discovery was a droplet refracting the light of possibility, building toward the realization that the cosmos may not merely tolerate water, but be suffused with it, waiting to be revealed. R&D to decode the cosmos through light. Each new generation of instruments sharpened that vision, peeling back layers of darkness to reveal the faintest chemical whispers. Detecting water was never as simple as finding liquid seas shimmering in the void. It was about unraveling hidden frequencies, delicate lines imprinted on the spectrum like ancient runes carved into the fabric of starlight. The power of radio, astronomy became central to this pursuit. Unlike visible light, radio waves could pierce the dust that veiled stellar nurseries, allowing astronomers to glimpse regions otherwise concealed. Within these frequencies, water molecules announced themselves through rotational transitions, tiny shifts in energy states that left clear, measurable signatures. To detect these signals across thousands of light years was an achievement of precision, requiring not only sensitive antennas, but also the mathematical patience to separate genuine signals from the static of the universe. Each detection, whether of a comet in the solar system or a tenuous cloud drifting through the Milky Way, added a droplet to an expanding ocean of knowledge. The work demanded cooperation on scales as vast as the discoveries themselves. Arrays of telescopes, spread across continents, were linked together in networks that turned Earth into a single giant ear pressed against the stars. Data from Chile's Atacama Desert would converge with signals collected in Spain or Hawaii, stitched together into a tapestry that revealed molecules invisible to any one instrument alone. These early detections carried a dual resonance. Scientifically, they built a catalogue of environments where water could exist to see, grains forming in cold nebulae, vapor clinging to newborn stars, frozen mantles locked into comets awaiting release. Philosophically, they deepened a growing awareness that water was not an anomaly but a theme, repeating itself throughout the cosmos, like a refrain in a timeless song. When placed beside the immensity of the quasar reservoir, these findings seemed modest, almost provincial, yet they were indispensable. Without the decades of careful spectroscopy, without the patient refinement of radio astronomy, the faint signals from a PM082 would have been lost in the cosmic roar. The quasar's discovery was not a sudden leap, but the crest of a long wave built from centuries of inquiry, carried forward by countless hands and minds across the world. To think of the universe as an ocean is no longer poetic exaggeration. The metaphor gains weight with each new detection, as though every star, every cloud, every comet is a drop contributing to an unseen sea. Humanity, standing on its small blue shore, has begun to glimpse the faint shimmer of this cosmic tide. The discoveries of the past were not endpoints, but waypoints, guiding science toward the realization that the universe itself may be steeped in water, abundant and waiting to be revealed. When the quasar APM 082 was mapped with greater precision, the outlines of its hidden environment began to emerge. Surrounding its black hole, matter spiraled inward in a luminous fury, releasing radiation so intense that it heated clouds of gas to extraordinary temperatures. Within these clouds, water vapor glowed faintly, each molecule radiating in patterns that could be read across billions of light years. What seemed at first an impossible discovery now revealed its physical logic: an ocean of vapor, suspended in the harshest of cosmic furnaces. The scale defied ordinary frames of comparison. Astronomers calculated that the reservoir contained thousands of times more water than exists in the entire Milky Way galaxy. Not merely more than Earth, not merely more than the solar system, but surpassing the combined reservoirs of an entire spiral galaxy. It was as though one corner of the cosmos had gathered enough of life's essential ingredient to drown imagination itself. Yet this was not water as a cradle of life. It was water locked in a paradox abundant but deadly. Bathed in radiation from a quasar brighter than 1,000,000,000,000 suns, the molecules existed in conditions no organism could endure. Instead of nourishing seas, they formed a cosmic mirage, shimmering with the promise of life, yet utterly inhospitable. The very substance that carved rivers and nurtured forests on Earth here drifted in a realm of destruction, caught in the gravitational grasp of a black hole feeding on its galaxy. For the teams of scientists studying the data, the moment carried the weight of recognition. What their instruments revealed was not simply a chemical detection. It was the largest reservoir of water ever found in the universe. Years of training, months of calibration, countless nights of staring into noise had distilled into this singular realization. In quiet rooms filled with screens and spectral lines, they had uncovered a discovery that shifted the scale of what humanity believed possible. The paradox deepened the mystery. How could the molecule most closely tied to life exist in such abundance in a place where life could never flourish? Some reflected that perhaps this was the nature of the cosmos itself, to scatter the ingredients of life widely, indifferently, without regard for where they may one day matter. Others saw it as a sign of universality, a reminder that life's foundation was etched into the very processes of galaxies, written into the dance of matter and energy at their cores. In this tension between abundance and hostility, between water's promise and its peril, the discovery revealed something profound. The universe was not barren of life's elements. It was saturated with them. And yet, where they appeared, they did not guarantee life, only possibility. The ocean around the quasar remained a mirage, dazzling, unreachable, but in its reflection, humanity glimpsed the quiet truth that water, like starlight, belongs not to one world but to the cosmos entirely. The deeper scientists probed the quasar's environment, the more extraordinary the details became. The water vapor was not randomly scattered. It formed within a turbulent region of gas and dust stretching hundreds of light years across. Heated to hundreds of degrees above absolute zero, these molecules glowed at sub-millimeter wavelengths, radiating energy that instruments on Earth could interpret. To detect them at such distances required exquisite sensitivity radio telescopes tuned to pick up signals that had traveled for nearly 12 billion years, weakened but still coherent, carrying across the gulf of time the story of a galaxy in its youth. Physicists traced the process to the furious activity of the central black hole. As matter spiraled inward, its gravitational energy converted into light, producing radiation that cascaded outward, heating surrounding gas and exciting the molecules suspended within it. Water, hydrogen, carbon monoxide, these building blocks of chemistry were energized like instruments in an orchestra, each emitting their own spectral notes. It was by reading this cosmic symphony that astronomers reconstructed the hidden environment around the quasar, mapping not only its contents, but also the physical laws that governed its turbulence. The scale of this water reservoir challenged imagination. It contained an estimated 140 trillion times the volume of Earth's oceans, diffused through clouds so vast that entire galaxies could be swallowed within their bounds. Unlike the familiar cycles of condensation, rainfall, and rivers on Earth, here the water existed as vaporized gas, sculpted by the violent currents of interstellar weather. There were no lakes, no streams, no gentle seas, only an endless vapor ocean, illuminated by radiation, yet unreachable by any conceivable vessel. Comparisons to the Milky Way underscored its strangeness. In our galaxy, water is patchy and scarce, concentrated in icy comets, dense molecular clouds, and the thin atmospheres of distant worlds. Here, in one corner of the ancient universe, there existed thousands of times more water than in all of the Milky Way combined. This contrast forced astronomers to reconsider how galaxies formed and evolved, and how elements essential to life could be distributed unevenly across cosmic time. Yet, for all its grandeur, the discovery carried an ironic melancholy. The water was abundant but sterile, present in conditions hostile to life. If liquid seas nurture life on Earth, then this vapor ocean represented the inverse life's ingredient captured in a place of death. The paradox was striking. The universe held both the seeds of habitability and their negation, often in the same breath. To find water here was like discovering fertile soil at the heart of a volcano rich in promise, yet rendered futile by its surroundings. The scientists who measured these signals knew they were documenting more than a statistic. They were witnessing a chapter in the cosmic biography of water, a chapter written not on Earth but inscribed across the sky billions of years ago. It was as if the universe itself was whispering that life's molecules are ancient and widespread, even if life itself is rare. And in that recognition, the discovery transcended numbers, becoming a meditation on abundance, fragility, and the delicate margins where possibility unfolds. The revelation of a quasar, harboring a vast ocean of water, was not an ending, but a doorway to deeper uncertainty. Why, in this place, at this time, did so much of the universe's most precious molecule gather? The numbers strained comprehension, enough vapor to drown whole galaxies, yet suspended in a space where no seas could ever form. It was as though the cosmos had hidden a riddle in plain sight, daring humanity to untangle its origins. Astrophysicists turned their focus to the conditions that could produce such a reservoir. At the heart of the quasar, a supermassive black hole feasted on its surroundings, its accretion disk glowing brighter than 1,000,000,000,000 suns. From this furnace, torrents of radiation poured outward, heating and stirring the surrounding gas. Dust grains, forged in the depths of ancient stars, acted as shelters for molecules, allowing fragile bonds to form even under the assault of high-energy photons. Water arose in this crucible not as droplets or streams, but as vapor clouds drifting through the turbulent interstellar medium. It was a chemistry of extremes, where destruction and creation interlaced like opposing tides. Competing interpretations soon emerged. Some suggested the reservoir was a relic, a leftover abundance from the early universe, preserved through cosmic time in the quasar's grasp. Others argued it was an active process, water continuously forming under the influence of radiation and shocks within the gas. In both cases, the implications were profound. If relic, it meant the universe birthed vast stores of water almost as soon as galaxies themselves came into being. If process, it meant that even in hostile environments, nature devised pathways for complexity, weaving water into the very architecture of galactic evolution. The distance of the quasar turned the mystery into something more intimate. What telescopes captured was not the water as it exists now, but as it was nearly 12 billion years ago, before the sun was born, before the Earth spun its first oceans. These signals were relic photons, bearing witness across cosmic time, arriving at Earth only now to tell their story. To study them was to peer into the adolescence of the universe, to discover that water, the elixir of life, was already abundant in that youthful age. The emotional weight of this realization was immense. Water was not an afterthought of cosmic history, not a late arrival in the quiet spiral arms of galaxies. It was present from the beginning, a thread woven through the very dawn of structure. It connected Earth's rivers and seas, two invisible clouds drifting around ancient quasars, binding the intimate and the infinite in one continuous tapestry. To drink from a glass of water on Earth is, in a sense, to taste the memory of the universe itself, and yet the paradox lingers. If water was already so common, if it filled the early cosmos in such profusion, why has life's voice been so silent? The discovery of this reservoir does not resolve that question, it deepens it. The universe, vast and ancient, has given its answer in molecules, but not in voices. Still, in the silence, water endures as a symbol, not merely of survival, but of possibility, a cosmic inheritance, flowing across time, waiting to be understood. To explore the mystery further, scientists delved into the physics of abundance. In the local universe, water is found in comets, in icy moons, in wisps of molecular clouds, but always in modest amounts, scattered like jewels across the void. Yet here, near a PM 082, the quantity defied precedent. Estimates suggested the vapor contained the equivalent of 140 trillion times all the water in Earth's oceans. It was not a pond nor a sea, but a cosmic deluge, compressed into a halo of energy surrounding a black hole. The numbers themselves became almost philosophical obstacles. Human minds evolved to comprehend rivers and lakes, the finite sweep of an ocean horizon. To multiply such volumes by trillions was to step beyond intuition. How could such immensity even be real? Yet the signals left little room for doubt. Molecular fingerprints in the far-infrared spectrum spoke clearly, resonating through multiple observations, verified by independent teams. The water was not an illusion. It was a fact, an immovable entry in the universe's ledger. Why, then, would the cosmos allow such reservoirs to exist in the shadow of annihilation? Water is tied so intimately to life, yet here it dwelt in regions bathed in radiation lethal to any biology. Perhaps this was the paradox the universe continually presents, the elements of life strewn far and wide, but rarely in the safe harbors where life might grow, or perhaps hidden in environments thought impossible. Chemistry had already taken steps humanity could not yet imagine. The quasar's water also reframed history itself. At the moment those photons began their journey, the Earth was not yet conceived. The Milky Way was still forming its spiral arms. And yet, in that embryonic epoch, the cosmos had already assembled an ocean so vast that it mocked human measures. Water, it seemed, was not the fragile rarity once imagined, but a fundamental feature of cosmic evolution, present nearly from the beginning. This realization bent time into a circle. The same molecule, two hydrogen atoms bound to oxygen, existed then as it does now, linking the early universe to the present moment. When an ocean wave breaks upon a beach, It is echoing chemistry that also took place 12 billion years ago, in a distant quasar's fiery embrace. Water is not bound to Earth, nor to life, nor to any one planet's destiny. It is the universe's handwriting, inscribed on scales that dwarf comprehension. Still, the enigma lingers. If water is so ancient, so plentiful, then why does the cosmos remain silent? Why have signals of life not accompanied signals of vapor? Some suspect the silence masks abundance, yet undiscovered. Others whisper that life may be rarer than the elements it depends upon. The quasar's ocean does not answer, only amplifies the question. It reminds humanity that the search for meaning is not a straight path, but a spiral, curving deeper with each discovery, and so the mystery deepens, not into despair, but into awe. The universe, it seems, has always been a sea. Earth is but one wave, breaking briefly on the shores of time, at the farthest reaches of human inquiry. Discovery often rests upon the thinnest threads of signal. The vast reservoir of water around the quasar APM 082 was not revealed in luminous clarity, but in faint tremors etched into the spectrum patterns fragile, enough to dissolve if the calibration of a receiver drifted by a fraction, or if the atmosphere above a mountain observatory thickened with passing clouds. Science at such distances is an act of balance, straining to separate the universe's whispers from the roar of cosmic background. Every telescope has its horizon. Beyond a certain distance, signals become buried in noise, photons stretched and weakened by the expansion of space until they nearly vanish. What remains is a ghostly trace, a memory of energy billions of years old. Radio astronomy has become the art of catching these final echoes, where certainty is won only through patience, repetition, and collaboration across continents. Yet, with each advance, the edge of vision extends. The IRAM array, the Herschel Space Observatory, and later, the Atacama Large Millimeter, Submillimeter Array pushed humanity's gaze deeper into the invisible. Perched on the high desert of Chile, ALMA's antennas stand like sentinels under the thin air, tuned to wavelengths capable of piercing cosmic fog. Here, the frontier is not merely distance but sensitivity, the ability to discern structure in the faintest glimmers of radiation. What earlier instruments hinted at, ALMA refines, painting clearer portraits of the unseen. Still, for all its power, even ALMA cannot capture everything. The universe holds regions where water may gather in still greater abundance, but their signals are smeared, redshifted, or hidden beneath interference. Some theories suggest that if a quasar can host trillions of ocean equivalents, then entire filaments of the cosmic web, vast tendrils of gas and dust might cradle reservoirs beyond anything yet measured. They remain invisible not because they do not exist, but because our tools are not yet sharp enough to cut through the haze. The fragility of knowledge is stark in this pursuit. A misstep in alignment, a fluctuation in the detector's sensitivity. Even a solar storm could mask or mimic the sought-after lines. Each observation demands not only precision, but humility, the recognition that certainty at such distances is never absolute, only asymptotic, approached through layers of confirmation. And yet, this very fragility is what lends discovery its power. To capture a molecule's fingerprint across 12 billion light-years is to prove that human perception can reach almost to the beginning of time. It is to glimpse the cosmos not as empty, but as saturated with matter, with water, with potential. Still, one question looms. If this much has been found with instruments that strain at the limits of their design, what remains hidden just beyond the threshold of detection? Perhaps the quasar's ocean is not an outlier, but the first drop of a revelation. Perhaps the universe itself is more like a vast, unseen sea, and humanity has only now dipped its hand into the shallows. At the edge of science, the line between knowledge and mystery does not divide, it shimmers, like a horizon, always retreating as the traveler approaches, into awe. Scientists pressed further, knowing that their instruments were both their greatest strength and their deepest limitation. Each observation was a triumph against the universe's vast indifference, but also a reminder of how much remained unseen. For every spectral line captured, countless others were lost to distance, obscured by cosmic dust or drowned in the low hum of the microwave background. Astronomy at these scales is less about light than about patience. Telescopes wait, listening, sometimes for years, until the same source is observed again, the data aligned, and the signal teased from noise. It is like reconstructing a melody from notes scattered across centuries, where each note risks being mistaken for static. The quasar's water was confirmed only because generations of scientists refined the discipline to this razor's edge, trusting equations to reveal order in apparent chaos. The Atacama Desert, where ALMA's array of antennas rises like a fleet of silent guardians, has become humanity's most ambitious outpost for this pursuit. Its altitude places it above much of Earth's atmosphere, removing the distortions of moisture and turbulence. In that stark landscape, each dish is tuned with exquisite care, capable of linking with its neighbors to simulate a telescope many kilometers wide. The result is clarity, an ability to trace faint emissions from water molecules across unimaginable distances. Yet even here, where precision reaches near perfection, the universe still withholds more than it gives. Some researchers speculate that the quasar's reservoir may be modest compared to other hidden giants. If water can form in such abundance under the violence of a black hole's radiation, then perhaps the filaments of the cosmic web where galaxies string together like pearls across hundreds of millions of light years could shelter reserves of even greater scale. Such structures, however, radiate faintly, their signals blurred by intervening epochs. The universe is generous in creation, but elusive in revelation. This constant tension defines the frontier of science. What is seen is astonishing, yet what remains beyond perception may be greater still. Humanity's instruments are like nets cast into an ocean, catching only what happens to drift near. For every molecule of water measured, trillions more may flow unseen through cosmic currents. Each discovery, then, is not a conclusion but an invitation, opening of doors into rooms still dark. In this light, the quasar's water becomes more than a marvel. It is a mirror reflecting the limits of current vision, a reminder that the story of the cosmos is only partly told. As instruments sharpen, as next-generation observatories like the James Webb Space Telescope and its successors push deeper into infrared and submillimeter domains, the horizon may shift again. What once seemed extraordinary may become common. What now feels like the edge may reveal itself as the threshold of a vaster sea, and so the scientists continue, eyes fixed on the sky, minds stretched across billions of light years, chasing whispers that slip between the stars. Each step forward is fragile, provisional, and yet unshakably profound. They are explorers, not of landscapes, but of limits, standing at the extreme edge of science, knowing the ocean before them has no end. The discovery of an ocean of vapor around a quasar did not appear, to most scientists, as an impossibility, but as an inevitability waiting for instruments sensitive enough to reveal it. Water, after all, is born from the simplest of ingredients, hydrogen and oxygen. Hydrogen, forged in the very first moments after the Big Bang, is the most abundant element in the universe. Oxygen, a heavier element, is created later in the hearts of massive stars and scattered outward in supernova explosions. When these two elements meet in the cold, dense environments of molecular clouds, water molecules form as naturally as do condensers on Earth's grass at dawn. Thus, the vast reservoir did not violate known laws of physics. It reflected them. Quasars, with their black holes feeding on torrents of matter, are surrounded by colossal clouds of gas and dust. Within those clouds, chemistry unfolds in quiet inevitability. Water emerges as a byproduct, not through rare accidents, but through processes so ordinary at cosmic scales that its absence, rather than its presence, would require explanation. Yet water is more than a passive trace. In astrophysics, it acts as a coolant, radiating heat away from collapsing clouds and allowing structures to condense further. Without molecular coolants, such as water and carbon monoxide, galaxies could not collapse efficiently, stars would form less readily, and the universe's architecture might look strikingly different. In this sense, water is not merely a witness to cosmic evolution, it is an architect, guiding the pace and form of creation itself. The quasar's water reservoir revealed this role on a scale previously unimagined. Heated by the radiation of the black hole's accretion disk, the vapor glowed in millimeter and sub-millimeter wavelengths, its spectral lines betraying its presence across billions of light-years. What appeared extraordinary was, in truth, a magnified version of processes occurring in quieter regions of space. Within the Milky Way, astronomers have catalogued smaller water mazes, natural cosmic lasers of microwave emission around star-forming regions, and even within the atmospheres of dying stars. The quasar was different only in scale, an amplification of a principle already written into the universe. From this perspective, the mainstream view grew cautious but confident. Such reservoirs might not be rare. They may simply escape detection because they require extreme conditions to shine brightly enough for telescopes to capture across the gulf of time. APM 082 offered an accidental alignment, a luminous beacon of radiation, a reservoir placed just so, and instruments tuned finely enough to hear its whisper. For every quasar that reveals its water, there may be countless others, hidden just beyond sensitivity, waiting for future observatories to uncover. The implications ripple outward. If water is this common, then the chemical richness of galaxies is far greater than once believed. The universe, in its earliest epochs, was not barren but already pregnant with the raw ingredients of stars, planets, and, eventually, life. To see oceans at the dawn of galaxies is to recognize that creation is not parsimonious but extravagant. The cosmos does not rationate overflows, and so, the leading theories do not portray the quasar's water as an anomaly, but as a revelation of abundance. The universe itself, it seems, has always been awash in hidden seas, their presence shaping galaxies in silence. Long before any world arose to wonder at them, to grasp the full meaning of this revelation, scientists turned toward the broad canvas of galaxy evolution. In the early universe, clouds of hydrogen and helium dominated. Over time, massive stars forged heavier elements, scattering them in titanic deaths. Oxygen, essential for water, was one of these stellar gifts. When it drifted into colder molecular clouds, it found hydrogen in overwhelming abundance. There, shielded by dust from ultraviolet light, water formed quietly, its molecules clumping in vast but unseen reservoirs. The quasar's water suggested that this process began astonishingly early. 12 billion years ago, only a fraction of the universe's current age, galaxies were still assembling. Yet already, the cycle of star birth and death had enriched their surroundings with enough oxygen to bind into oceans of vapor. This painted a universe not of scarcity, but of rapid chemical fertility, evolving far faster than once thought possible. Astronomers compared the quasar's reservoir to more familiar water sources within the Milky Way. In our galaxy, water is detected in giant molecular clouds and within the envelopes of forming stars, but never in quantities even approaching the quasar's abundance. The contrast highlighted both the extremes of the early cosmos and the biases of detection. Nearby regions appear modest only because our galaxy is older, quieter, its violent youth long past. The quasar revealed what happens when those same processes are magnified. Driven by a black hole feeding at a rate thousands of times higher than normal stellar nurseries, this led many to propose that reservoirs like this may be common, though hidden. Only the brightest quasars, aligned just so, produce the conditions necessary for telescopes to catch the glow of water molecules. The rest remain concealed, awaiting future observatories with sharper vision. The James Webb Space Telescope has already begun to extend this frontier, with its infrared instruments tuned to detect faint chemical signatures across extreme distances. Yet even Webb is a stepping stone. More advanced arrays will be needed to map the true scale of cosmic water. The mainstream interpretation, then, is one of continuity rather than anomaly. The quasar's ocean is extraordinary not because it is unique, but because it is visible. It stands as proof that water has been abundant since galaxies first lit the darkness, woven into their very dynamics. In this vision, the universe is not a barren expanse punctuated by rare oases. It is a cosmos already soaked in hidden seas, their waves shaping galaxies in silence. Long before any eye could see them, beyond the boundaries of accepted models, lies a realm of speculation ideas that drift like cosmic mirages, shimmering with possibility but unanchored to proof. Here, water ceases to be only a chemical and begins to play the role of myth, symbol, and cosmic constant. Some theorists envision the vast reservoirs as precursors to habitable zones, the scaffolding upon which galaxies build their potential for life. In this view, oceans of vapor do not simply cool gas and trigger stars. They seed the environments where planetary systems may later inherit both moisture and chemistry. Such clouds could act as cosmic reservoirs of promise, storing the ingredients of habitability long before planets are born. The notion stretches into the philosophy of panspermia. If comets and asteroids carry fragments of ice and organic molecules, could not these galactic oceans be the ultimate source? A reservoir around a quasar, enriched with carbon, nitrogen, and oxygen, might serve as the cradle for molecules that later ride interstellar debris into young planetary systems. Life, in this telling, becomes a traveler whose passport is water, carried across light years by the silent currents of galactic tides. Others push the speculation further, imagining these reservoirs not only as stores of chemistry, but as nurseries of self. In conditions of pressure, turbulence, and radiation, could complex molecules have begun to weave themselves into patterns, a faint rehearsal of biology itself? It remains a fringe suggestion, lacking empirical grounding, yet it carries a haunting allure. The possibility that life's first whispers may not have begun on planets at all, but within the fog of interstellar seas. More radical voices connect this abundance of water to the fabric of cosmology itself. Some multiverse theories suggest that universes vary in their constants, each with different rules of physics. In such a landscape, the prevalence of water may hint at fine-tuning. A cosmos with different ratios of hydrogen or oxygen might never see liquid seas, and thus never cradle observers to wonder at their absence. Water, in this speculation, is not incidental, is a signature of a universe aligned toward chemistry, complexity, and reflection. At the farthest fringe lies an almost poetic vision. The water itself is a cosmic constant, more fundamental than the stars it cools or the galaxies it sculpts. A fluid that remembers creation, encoded in its bonds the story of light's first victories over darkness. To some, every drop on Earth is a fragment of that memory, a molecule once forged in the furnaces of ancient stars, carried across epochs to fall as rain upon human skin. Science remains cautious. These ideas live at the edge of imagination, yet they serve a purpose. They remind us that discovery is not only a catalogue of facts, but also a dialogue with wonder. In gazing at the hidden oceans of the cosmos, humanity confronts not only the chemistry of galaxies, but the possibility that water is the universe's own handwriting, a script still being read, molecule by molecule, across the silent deep. The discovery of water on such an unimaginable scale has set in motion a new chapter in astronomy, an era defined not only by questions of origin, but by the precision of the tools that may provide answers. The James Webb Space Telescope, with its infrared eyes, has already begun to map molecules across the deep sky, sensitive to the faint fingerprints of water vapor, carbon dioxide, and methane. It can reach back across cosmic time to witness chemistry unfolding when the universe was only a fraction of its current age. Its instruments peel back veils of dust that obscure optical telescopes, revealing the molecular structures that once eluded human vision. Yet Webb is only the beginning. On Earth's highest plateaus, where thin air and dry skies reduce atmospheric interference, a new generation of radio arrays is taking shape. The Atacama Large Millimeter Submillimeter Array has already revolutionized the field, but even more ambitious designs are on the horizon. The Square Kilometer Array, spreading across South Africa and Australia, promises sensitivity beyond anything yet imagined. Its sheer size, composed of thousands of antennas working in unison, will allow astronomers to trace molecular signatures with unprecedented clarity, distinguishing the faint whisper of water from the roar of cosmic background radiation. The challenge is not only in building instruments, but in deciphering their flood of data. Each observation produces torrents of information, far beyond the capacity of traditional analysis. Artificial intelligence has emerged as a necessary partner, trained to recognize patterns invisible to human eyes. Machine learning algorithms sift through the noise, separating chance alignments from genuine molecular signals, drawing maps from fragments of radio static. In many ways, these algorithms extend the reach of human perception, allowing scientists to explore dimensions of subtlety inaccessible to unaided thought. Such efforts are not bound by national borders. The search for water across the cosmos has become a collective endeavor, with international collaborations pooling resources, expertise, and ambition. From Chile's desert to Hawaii's volcanic peaks, from orbital observatories to remote supercomputing centers, humanity works as a distributed intelligence, united in the pursuit of a cosmic cartography. Each discovery is added like a stroke of watercolor to a vast, unfinished map drawn not in light alone, but in water. Comparative studies form the heart of this undertaking. The quasar's reservoir is extraordinary, but astronomers now search for echoes of its abundance around other quasars and galaxies, testing whether it is unique or merely the first glimpse of a hidden pattern. Early hints suggest that water may indeed be common, though concealed within the turbulence of distant galactic hearts. If confirmed, this would reshape our view of cosmic evolution, transforming water from a rarity into a fundamental thread of structure and growth. There lingers a vision, both scientific and poetic, that one day humanity may hold a complete map of the universe traced by water, not a map of stars or galaxies alone, but of the silent oceans drifting between them, a cartography of chemistry that reveals not just where matter resides, but how it breathes, cools, and evolves. In such a vision, the universe becomes not an empty void punctuated by light, but a vast and interconnected sea, in which Earth's rivers and oceans are but small reflections of a greater, timeless whole. From the beginning, water has been the element through which humanity understands itself. It is the mirror of the sky, the weight of oceans pressing against the continents, the silent memory written in ice. And now, in the faint signals drawn from a quasar, billions of light-years away, water is revealed as a cosmic presence stretching far beyond the Earth, far beyond the solar system, woven into the very architecture of galaxies. The contrast is almost unbearable in its beauty. A small blue planet, floating in a black void, home to rivers and seas, storms and tears, yet surrounded by an invisible ocean that spans the universe. Earth is not a singular oasis, but a reflection of a much deeper truth. Water belongs not just to this world, but to the cosmos itself. For philosophers and scientists alike, this revelation stirs the question of life. If water has always been present since the earliest galaxies, since the dawn of stars, then what does that say about the potential for life beyond Earth? No longer must it be imagined as a fragile accident in a barren universe. Instead, life may be a natural flowering in a cosmos already seeded with its essential ingredient. Perhaps every droplet here is echoed by unseen droplets there, carrying the same promise in other corners of the sky. History seems to echo through this moment. Once, explorers stood on Earth's shores, gazing out at oceans that seemed infinite, unsure what lay beyond. Now, humanity stands at a similar threshold, looking not at blue waves, but at invisible reservoirs, mapped in wavelengths of light. The same awe that once drove ships across seas now drives telescopes across the heavens. Each discovery carries the same pulse of curiosity, the same refusal to accept the limits of the known world. In the end, the vision that emerges is not of a barren, empty cosmos, but of a universe alive with hidden rivers, not rivers of water alone, but of time, matter, and memory currents that connect the Earth to the farthest quasar, the smallest droplet to the largest reservoir. Humanity is not apart from this flow, but within it, a fleeting awareness carried on the tide. Water, it seems, is the thread, a bridge between the finite and the infinite, a reminder that the same molecule that falls as rain on Earth drifts also in the hearts of galaxies, whispering across billions of years. To discover this is to recognize that the universe is not only a stage for life, but perhaps already a part of its unfolding story, a story written in rivers of light, in oceans of shadow, and in the timeless chemistry of water. The discovery of a quasar's vast reservoir of water, billions of light-years away, becomes more than a scientific finding. It becomes a mirror, forcing humanity to confront its place in the universe. Water has always been the medium through which civilizations shaped myth, ritual, and survival. Rivers defined boundaries, oceans carried explorers into the unknown, and rain became both blessing and threat. To now glimpse that same element woven into the deep fabric of the cosmos is to sense continuity on a scale both humbling and sublime in one vision. Earth appears fragile, a luminous droplet suspended in endless dark. The seas that cover 70% of its surface suddenly feel provincial, like ponds within a greater ocean that humanity has only begun to perceive. What was once considered boundless is now revealed to be finite, while the true immensity of water lies scattered invisibly among the galaxies. This reversal of scale unsettles the mind. Earth's defining element, that which seemed abundant and secure, is but a fraction of a cosmic reservoir beyond reach. For philosophers, this realization calls forth ancient questions in a new guise. Is life an exception, a statistical miracle born from chance alignment? Or does water's ubiquity hint at inevitability, that given time, matter, and chemistry, life may emerge wherever water flows? The molecules observed in the quasar's embrace have existed for billions of years, enduring through cosmic violence, radiation storms, and the gravitational tides of black holes. Their persistence speaks of resilience, a resilience mirrored in life itself. Perhaps water does not merely accompany life, but foreshadows it, laying foundations for patterns that biology will one day inhabit. Scientists reflect on the paradox. Here is water, the most essential ingredient for life, detected in a region utterly hostile to living systems. Around a quasar, radiation is intense, temperatures extreme, and gravitational fields inexorable. Yet water thrives, not as liquid seas, but as vapor, heated and suspended in turbulent clouds. It is as if the universe is reminding us that its logic differs from ours, that symbols of life may exist in zones where life cannot endure. The paradox forces humility, revealing that human categories safe versus hostile, habitable versus barren are small frameworks. When set against cosmic reality, this awareness leads to an existential duality. On one hand, water's abundance inspires hope. If it pervades the universe, then perhaps life too is widespread, awaiting discovery. On the other hand, the distances involved render such life unreachable, turning abundance into isolation. Humanity may dwell in a cosmos brimming with potential companions, yet remain forever silent within its own island of space-time. It is a thought both exhilarating and devastating, the possibility of a crowded universe, perceived only through echoes too faint ever to answer back. The cultural resonance of this discovery stretches beyond laboratories and observatories. Artists envision cosmic oceans painted across canvases of imagination. Poets speak of rivers of light, galaxies as drops scattered across eternity. Philosophers frame water as memory molecules forged in stellar furnaces, carried by comets, locked in ice, now traced in wavelengths older than Earth itself. Each interpretation becomes an attempt to integrate this discovery into human meaning, to transform raw data into story. History, too, provides its parallels. Centuries ago, when early explorers first crossed uncharted seas, they extended maps into blank spaces filled with speculation and myth. Dragons once marked the edges of known waters. Now, the unknown is not an ocean of salt, but of hydrogen and oxygen molecules stretched across intergalactic voids. Where once wooden ships carried sailors into storms, now radio waves carry signals into silence. The spirit, however, remains unchanged, the refusal to accept the horizon as the end, the insistence that the world is larger than the world already known. The philosophical implications run deeper still. If water is so pervasive, then perhaps life is not only possible but expected. In this sense, humanity may not be unique, but typical an expression of universal chemistry repeating itself across scales. Yet there lingers another possibility, that water is abundant, but life rare. That chemistry provides opportunity, but consciousness requires circumstances so precise they may occur only once. Between these two possibilities, the crowded cosmos and the solitary one humanity oscillates. Caught between hope and dread, the emotional contrast remains stark. Earth is a sanctuary of blue, its oceans teeming with creatures, its rains feeding forests, its rivers carving valleys. Beyond it lies the black void, seemingly empty, yet proven not to be barren. The cosmos is filled with hidden oceans, silent and unseen, their presence betrayed only by delicate imprints in radiation. Humanity now recognizes itself, not as alone, but as immersed in an unseen sea that binds galaxies to one another. Water, in this sense, becomes a metaphor for unity. It is the bridge between planets, between stars, between epochs. The molecule that once fell as rain upon the first continents may share its essence with the vapor detected near a quasar, separated by distances inconceivable. The same chemistry threads across time and space, weaving a continuity that makes the universe less alien, more familiar. To contemplate this is to sense kinship with the cosmos, a recognition that humanity's story does not unfold in isolation, but as part of a broader narrative written in the language of water. And so the chapter closes with a vision both scientific and poetic. Humanity, standing at the edge of understanding, peers into the void and discovers not emptiness, but rivers, not deserts, but reservoirs, not silence, but echoes. The universe is no longer seen as a barren stage, but as a flowing system, where water life's constant companion moves unseen through billions of years. To bear witness to this truth is to step into a new identity, not as dwellers of a lonely planet, but as participants in a cosmic ocean still being charted. Yet this vision does not end in certainty. It ends in reflection. Are humans droplets in a universal tide, part of a larger living system yet undiscovered? Or are they solitary, the only awareness adrift in a sea of indifferent molecules? Both answers are possible, and both carry weight. Perhaps the true significance lies not in choosing, but in recognizing the depth of the question itself. To ask it is to acknowledge kinship with the stars. In this recognition, water ceases to be merely a chemical compound. It becomes a symbol, memory, and promise. It becomes the link that binds Earth's fragile blue with the unseeable reservoirs of the cosmos. To look upon it is to glimpse continuity stretching from raindrops to quasars, from tears to tidal waves, from the human story to the universe itself. And in that reflection, humanity may finally understand it has never been alone, for it has always been carried by water, and water is everywhere. The reflection continues, deepening like a river winding toward the sea. Some argue that the greatest revelation lies not in the discovery of water itself, but in the shift it demands of perspective. For centuries, humans imagined themselves central, their world unique, their oceans unmatched. Now, the cosmos answers with scale, reminding them that what feels extraordinary here is ordinary there. The universe does not hoard its water. It disperses it, sows it across gulfs of space. In doing so, it redefines Earth not as an exception, but as an expression. The implications reach into ethics and responsibility. If water is abundant in the universe, then life's potential is vast. Earth, as the one confirmed world of life, becomes precious beyond measure. To squander its oceans, to poison its rivers, is not merely a local failure, it is a betrayal of a universal heritage. The discovery of cosmic water reframes environmental stewardship. Earth's water is not isolated, but connected to a larger continuum. To protect it is to honor that connection, to act as custodian of something shared with the stars. The thought inspires reverence. Each drop of rain is no longer just weather, but a fragment of cosmic history, recycled across eons, carried from the birth of stars to the beating of hearts. To drink water is to taste time, to participate in a cycle older than continents, and now older than galaxies. It is to join a ritual that stretches beyond the planet itself, linking body to universe in every swallow. In the silence of deep observatories, astronomers often speak of wonder not as answer but as presence. The data, stripped of poetry, describes molecular spectra, energy levels, and radiative transitions. Yet the reality those numbers encode is breathtaking. Clouds of water vapor larger than galaxies, surviving in the embrace of black holes. Behind the technical jargon lies awe. a recognition that to measure such things is to glimpse the unimaginable. And still, questions multiply. How many more reservoirs remain hidden? Are they scattered across every quasar, or rare jewels among billions? Could entire galaxies be woven with water in forms yet undetectable? Each answer unfolds into further mystery, each discovery into deeper ignorance. The ocean grows vaster the more it is mapped, just as ancient sailors learned that beyond every horizon lay another. The human element is never absent. Behind each signal lies decades of labor scientists hunched over monitors, engineers designing instruments, programmers shaping algorithms. Their efforts converge into moments when faint lines on a graph reveal truths older than the solar system. In those moments, the personal becomes cosmic. Late nights, errors, recalibrations, transformed into revelations that alter how the species sees itself. Perhaps this is the final meaning of cosmic water, that it binds not only stars and galaxies, but also minds and generations. It unites myth with measurement, poetry with physics, history with future. It is both a scientific fact and a philosophical symbol, equally at home in laboratories and in stories told by firelight. In it, humanity finds reflection not just of oceans and rain, but of its own thirst to understand, to seek continuity in a universe of seeming fragmentation. Thus the discovery remains unfinished, an open chapter in a book still being written. The universe continues to flow, and with it, human thought. What began as a faint signal in radio waves becomes an enduring metaphor, carrying science and philosophy alike upon its current. Water, as always, moves unseen yet essential, shaping not only landscapes but consciousness. And as long as it does, humanity will look outward, searching for its reflection in the stars, knowing that somewhere in the darkness, rivers are waiting. Mathematics, imagination with evidence. It is the rare element that traverses boundaries, dissolving the division between science and spirit. The ancients who revered rivers as sacred veins of the earth were not wrong, merely incomplete. Their intuition sensed a truth that modern astronomy now expands, that water is not confined to earth, nor to myth, but is the common thread of a universe both material and symbolic. In reflecting on this, humanity encounters a peculiar inversion. For millennia, people looked upward in search of gods and looked downward in search of survival. Now, telescopes reveal that what was sought above and what was sustained below are one and the same. The rain that nourishes crops is cousin to the vapor swirling around quasars. The cycle of evaporation and precipitation finds its mirror in the circulation of cosmic clouds, heated and cooled across epochs. This recognition collapses the divide between heaven and earth, suggesting that the sacred is not separate but continuous. Such continuity urges reconsideration of human identity. If water connects Earth to the universe, then the species itself becomes an extension of cosmic chemistry. The body, composed mostly of water, is not merely a vessel but a microcosm. Every heartbeat is a ripple in this grand reservoir, every tear a testament to unity with galaxies. To feel thirst is, in a sense, to echo the quasar's vapor, to be bound by the same molecular signature that pervades the interstellar medium. This realization carries with it both comfort and weight. Comfort, because it implies kinship. Humanity is not foreign to the universe, but fashioned from its most familiar elements. Weight, because such kinship demands responsibility. To honor the water within, one must honor the water without. The rivers, glaciers, and oceans of Earth are not possessions, but relatives, manifestations of the same substance that hums through nebulae and star systems. And yet, even as this connection deepens, the mystery grows sharper. For if water is so widespread, Why does life seem so elusive? Where are the voices, the civilizations, the echoes of others who must surely exist? Some scientists invoke the Fermi paradox here, the disquieting silence of a universe that seems primed for life, yet remains mute. The abundance of water sharpens this paradox rather than softens it. It amplifies the question, if the conditions are common, why is life not also common? Perhaps the answer lies in thresholds. Water may be abundant, but stability is rare. To sustain life requires more than ingredients, demands balance, time, and protection. A planet must orbit at the right distance, shield itself with magnetic fields, recycle nutrients, and endure without catastrophe long enough for complexity to bloom. The cosmos may indeed be full of water, but only a few worlds may cradle it as seas, lakes, and rivers under gentle skies. In that rarity lies both tragedy and wonder. Tragedy that life may be sparse, wonder that it exists here at all. The thought leads to an image, earth as a chalice, brimming with water drawn from universal wells, yet balanced so delicately that a slight tilt would spill it into desolation. The planet's blue glow becomes less a symbol of abundance and more of fragility. Its oceans, once believed infinite, now appear finite mirrors of countless unseen oceans that will never touch its shores. To gaze at Earth from space is to see not dominance but vulnerability, a vessel floating in a sea too vast ever to cross. Yet perhaps it is precisely this fragility that gives the human story its urgency. Knowing that water exists elsewhere but cannot be reached in lifetimes demands reflection on what can be reached. The streams that run dry, the aquifers drawn too deep, the glaciers melting into memory. To revere cosmic water is to awaken responsibility toward terrestrial water. The stars remind humanity not only of grandeur but of obligation. Philosophers of old might have called this revelation fate or providence. Modern minds may call it probability or thermodynamics. But whatever the name, the essence remains. Water is the bridge. It carries meaning across cultures, across centuries, across galaxies. It dissolves boundaries and insists on unity, not through force but through persistence. It is the gentle inscriber of valleys, the shape of atmospheres, the eroder of stone and certainty alike. The chapter turns, then, toward a vision of future exploration. Humanity may one day send probes to icy moons, drill through Europa's crust, sail Titan's methane seas. Each endeavor will not only be a search for alien biology, but a continuation of an older quest to follow the water, wherever it flows, and to ask what stories it carries. In that pursuit lies both scientific progress and spiritual continuity. The next stanza in an ancient poem, perhaps the final reflection, belongs not to the scientists, but to the poets. They remind us that water is not only molecules, but metaphors, not only data, but dreams. It is memory, because it carries the imprint of all who have touched it. It is time, because it cycles endlessly, returning transformed yet familiar. It is silent, because it speaks without words, whispering in tides and vapor. And it is a promise, because it suggests that life, in some form, may always be waiting just beyond the horizon. Thus, the vision closes. Humanity, fragile and finite, stands on the shore of an infinite ocean, aware now that the sea does not end at the horizon but continues into the stars. To know this is not to end the journey, but to begin it anew. For water has always guided humanity from river valleys to open oceans, and now it guides them still into the cosmos. The rivers of earth flow toward the seas. The seas flow into clouds. The clouds drift into stars. And beyond the stars, unseen rivers continue, vast and eternal. Humanity, carried by them, has only begun to learn how to listen. To honor the water within, one must honor the water without. The rivers, glaciers, and oceans of earth are not possessions, but kin manifestations of the same substance that hums through nebulae and star systems. The more deeply humanity contemplates this connection, the more water becomes a teacher. It teaches patience, as glaciers grind mountains over millennia. It teaches persistence, as rivers carve canyons over eons. It teaches transformation, as vapor turns to rain, ice to liquid, droplets to waves. And in the cosmos, it teaches humility. Vast clouds of water vapor orbiting black holes remind humanity that nature's patterns extend far beyond comprehension, that existence itself is sculpted by forces both familiar and alien. The presence of water in hostile regions of space illuminates another paradox, that what sustains life here survives in places where life cannot. Around quasars and neutron stars, water persists in forms stripped of their nourishing role, mere molecules adrift in violent storms. In this sense, the cosmos holds mirrors of earthly elements, but not earthly purposes. Life seems to be an exception, a fragile organization of matter that takes what the universe offers, molecules, energy, time, and bends them into awareness. This recognition deepens the existential question: is consciousness itself a cosmic rarity, or is it an inevitable flowering wherever water and chemistry combine under stable skies? The silence of the stars leans toward rarity, but the ubiquity of water leans toward inevitability. Between these two poles, humanity lives suspended, neither comforted by certainty nor abandoned to despair. The tension itself may be the essence of the searcher, constant oscillation between solitude and communion. And as humanity searches, water continues to serve as a metaphor for their own journey. Explorers once pushed ships beyond sight of land, trusting currents they did not fully understand. Today, spacecraft sail radio waves and plasma winds, guided by physics but carried by the same spirit of surrender to the unknown. Just as ancient sailors depended on tides, modern astronomers depend on the invisible tides of radiation that carry signals. Across billions of years, there is poetry in this continuity. The same element that carved valleys and guided ships now guides equations and instruments. The same restlessness that drove wooden holes into tempests now drives humanity to peer beyond galaxies. Every discovery is another shoreline, another continent glimpsed beyond the horizon. And water always watermarks the path in the quiet corridors of observatories. One can almost feel this continuity embodied. Scientists speak in the language of spectra and frequencies, yet beneath their words is reverence. A faint signature of vapor detected in a quasar's halo becomes not only data, but revelation. It affirms that the universe holds reservoirs older than Earth itself, patient and enduring, as though waiting to be seen. To sense this is to glimpse unity at a scale too vast to fully comprehend. It is to realize that Earth's oceans are not isolated wonders, but small tributaries of a cosmic river flowing unseen. Humanity drinks from that river daily, carries it within their veins, and dreams of it in myth and song. And though they may never touch the distant waters of quasars, in knowing they exist, humanity becomes more than a witness. They become participants in a universe that is not empty, but flowing, and so reflection continues, unending as the current. Water connects the first rain to the last tide, the cry of a newborn to the vapor swirling around a dying star. It is thread, cycle, and memory. It is the reminder that in every molecule lies a story, written not only on Earth, but across the galaxies. Humanity, fragile and finite, is bound by that story, carried upon its tide. and destined to follow wherever the river of the cosmos may lead. S shows itself as both generous and indifferent. It provides the essential building blocks of life, yet scatters them into voids where no organism can endure. This duality forces reflection upon the human condition. Existence flourishes not because the universe bends toward life, but because, in rare havens, matter aligns in delicate balance. Water is everywhere, yet only in a narrow range of circumstances does it become the cradle of biology. Such awareness sharpens the philosophical paradox of abundance without guarantee. If galaxies teem with vaporous oceans, yet remain barren of creatures, then water is revealed not as destiny but as possibility. The cosmos offers ingredients, not promises. In that offering lies both freedom and uncertainty. Humanity, with its fragile biology and restless intelligence, becomes the interpreter of this ambiguity, forever caught between awe and doubt, and yet awe continues to outweigh despair. For in contemplating cosmic waters, one discovers a sense of scale that humbles and elevates simultaneously. A droplet on a fingertip holds kinship with clouds billions of light-years away. This recognition stretches imagination across gulfs of time and distance, dissolving the illusion of separateness. The same element that once cooled volcanic earth and pooled in primordial seas now traces filaments across intergalactic space. To perceive this is to stand at the edge of eternity and feel both infinitesimal and infinite. The philosophical weight of such discoveries has begun to ripple into culture. Artists, poets, and thinkers borrow the language of astronomy to describe longing, unity, and change. Water becomes a metaphor not only for emotion, as it always has, but for existence itself. A verse about tears may carry within it the echo of quasars. A painting of a river may now be understood as kin to interstellar streams of vapor. Science does not diminish the metaphor. It expands it, rooting symbolism in physical truth. From this expansion arises a profound sense of responsibility. If water is not an earthly resource, but a cosmic inheritance, then to pollute rivers and drain aquifers is not only environmental neglect, but philosophical blindness. The streams of earth are not separate from the streams of the cosmos. They are continuations, local expressions of a universal pattern. To diminish them is to sever one's connection to a story billions of years old. Thus, reflection folds back upon humanity itself. What does it mean to live as creatures made mostly of water, dwelling on a planet of oceans, in a universe laced with vapor? Perhaps it means that identity must be understood less as isolation and more as flow. Each human being is not a closed system, but a current, shaped by forces before birth and carried toward destinies unknown. In this vision, individuality becomes less like a stone and more like a wave, distinct in form yet inseparable from the sea. And in that sea, stretching from earth to the edges of the observable universe, water whispers its lesson. Nothing stands alone. Every droplet belongs to the cycle, every river to the basin, every cloud to the sky, every molecule to the cosmos. Humanity is not apart from this truth, but a late-born witness to its grandeur. To live with that knowledge is to live not as conquerors of nature, but as companions in its eternal unfolding. S becomes a mirror of human resilience. Just as individuals endure amid adversity, water endures amid extremes, surviving radiation, turbulence, and the gravitational pull of collapsed suns. Its persistence becomes emblematic of the universe's quiet insistence on continuity. No matter how chaotic the setting, from this persistence arises a question, both scientific and existential. Is water not only a substance, but a principle, a law written into the very equations of creation? The universe produces it wherever conditions allow, as though compelled to weave this molecule into the fabric of time. Hydrogen, the simplest and most abundant element, joins with oxygen, forged in stellar furnaces, to create a bond that is at once fragile and indestructible. This bond, repeated countless trillions of times, saturates galaxies with hidden oceans. It is as though the cosmos is telling a story with only a few letters, repeating the word water across every page. The human imagination, confronted with this repetition, wanders into speculation. If water is everywhere, then might life be everywhere too, not as identical forms, but as variations shaped by alien shores. Perhaps there are worlds where seas stretch beneath violet skies, where rivers of unfamiliar chemistry flow yet echo the same logic of Earth's hydrological cycle. In such visions, water becomes the architect of diversity, seeding forms of consciousness that may never resemble humanity, but share its essence, to emerge from liquid and reflect upon the infinite, even without evidence of such companions. The philosophical weight remains. The discovery of cosmic water shifts humanity's perception of solitude. A blue planet drifting in darkness no longer seems like an isolated miracle, but a node in a vast interconnected web. Earth's oceans are revealed not as anomalies, but as local manifestations of a universal abundance. In this light, to gaze upon the sea is to glimpse the structure of the cosmos itself, and with that realization comes a deeper humility. Just as ancient navigators once looked upon the horizon and knew they were part of something larger than their immediate shores, so too does modern humanity look upon cosmic waters and feel the pull of a greater belonging. The universe does not answer questions directly, but it offers clues, scattered like droplets across the expanse. To gather those clues is to participate in a story larger than survival, a story of resonance, of recognition, of kinship. In the quiet of reflection, the lesson crystallizes. The universe is not barren, but flowing. Its rivers may not always nourish life, but they nourish meaning. To understand this is to stand at the confluence of science and philosophy, where data becomes metaphor and molecules become memory. Humanity, fragile yet enduring, becomes both student and storyteller, translating the silent language of water into a vision of belonging. Each new realization about cosmic water deepens the tension between human insignificance and human significance. On one hand, water's ubiquity diminishes Earth's claim to uniqueness. Oceans once considered miraculous now seem inevitable byproducts of cosmic chemistry. On the other hand, the very act of discovering water billions of light years away marks humanity as extraordinarily one small species, able to sense, imagine, and interpret the invisible reservoirs of the universe. This paradox is at the core of reflection. The cosmos both humbles and elevates. The same molecule that erodes mountains and carves valleys has now carved a path into human consciousness, forcing a re-examination of what it means to exist. Water is no longer just a physical necessity, but a philosophical invitation, urging humanity to see itself as a participant in a dialogue stretching across eons. Consider the image of Earth suspended in space, a sphere shimmering with blue oceans, veined with rivers, crowned with clouds. For millennia, this sight was inaccessible, imagined only in myths of celestial domes and watery firmaments. When the first photographs from Apollo revealed Earth against the void, a transformation occurred. Geopolitical boundaries shrank, and the planet appeared as one fragile oasis. Now, with evidence of immense water reservoirs beyond the Milky Way, the transformation deepens again. Earth's blueness is no longer a solitary distinction, but part of a hidden spectrum woven through the universe. Philosophers often speak of archetype symbols that repeat across cultures and epochs. Water has always been such an archetype, a representation of renewal, birth, destruction, and transcendence. What science now confirms is that this archetype is not only cultural, but cosmic. The symbolism of water arises not from human imagination alone, but from the molecule's persistence across galaxies. It is a pattern written into nature itself, mirrored by myth, because myth has always been humanity's attempt to echo the real. The implications are profound. If water is a constant thread, then perhaps consciousness itself is not as improbable as once thought. Life may not be an isolated flame flickering in an otherwise inert cosmos, but one among countless lights sparked by the same elemental fuel. Even if only a fraction of those sparks endure, the possibility alters the philosophical landscape. Humanity is not merely asking whether life exists elsewhere, but whether life is the expected outcome of a universe where water flows like an unseen tide. And yet, reflection must pause at humility. Water alone does not guarantee life. It only opens the door. The quasar's reservoir, vast though it is, remains inhospitable. Radiation sears, gravity crushes, and no organism could endure within its violent embrace. Here lies the paradox most haunting of all, life's essential ingredient, existing in abundance where life itself cannot survive. This paradox challenges human assumptions, reminding that the universe does not follow the logic of desire. It follows its own indifferent rhythm, scattering beauty into places where it cannot be touched. In this rhythm, however, there is resonance. Humanity, through the act of knowing, bridges the gap between the hostile and the habitable. Though no creature drinks from the quasar's waters, the knowledge of their existence nourishes human thought. Ideas flow where biology cannot, and in that flow, the boundaries of existence expand. The discovery becomes not merely scientific, but existential, evidence that the universe, even in its harshest forms, remains bound to humanity by threads of recognition. As centuries advance and instruments sharpen, the philosophical weight of these discoveries may grow heavier. Future generations could inherit a sky mapped not by stars alone, but by rivers of molecular signatures. To them, the universe will appear less like a void and more like a basin filled with unseen oceans. Their challenge will not be to ask if they are alone, but to ask what kind of kinship they wish to imagine with the cosmos that surrounds them. And so the reflection turns inward once more. A glass of water on a table, a wave breaking on a shore, a droplet clinging to a leaf at dawnage, becomes more than a mundane occurrence. Each becomes an echo of reservoirs stretching billions of light years away. To drink is to participate in a cosmic story, to be joined to galaxies by invisible currents. The act of living itself becomes a ritual of connection, performed daily without recognition, yet monumental in implication. Thus, the chapter of reflection closes, not with certainty, but with continuity. Water is both symbol and substance, necessity and mystery, local and infinite. It teaches that survival is only the beginning. That meaning emerges when molecules are seen not only as matter, but as metaphor. Humanity stands, therefore, at the edge of a cosmic shore, aware that the tide extends far beyond sight. Whether that tide carries other forms of life, other stories, or only silence, remains unknown. But the awareness itself is enough. It binds Earth to the farthest quasar, and the human heart to the memory of creation. The reflection deepens as science meets myth, and myth bends toward science. In every civilization's memory, water was always more than substance. It was chaos and creation in Mesopotamia, the endless flood that birthed gods in Egypt, the sacred Ganges flowing from heaven in India, the tears of primordial beings in Mesoamerican tradition. Now, through the lens of telescopes and mathematics, these myths seem less like fiction and more like the first metaphors for a truth that surpasses human scale. Water is not confined to one world, but belongs to the universe itself, Yet the resonance is not only poetic, it is measurable. Spectroscopy, the art of reading light, transforms the invisible into language. In a quasar's spectrum, faint patterns reveal water molecules drifting across billions of light years, their vibrations encoded in microwaves. Each signal is unimaginably fragile, a whisper barely distinguishable from the cosmic background. And yet, through careful calibration and patience, humanity extracts a story. It is as if the universe, silent and vast, has left messages hidden in the very fabric of light, awaiting discovery by minds willing to listen. This act of listening becomes an act of philosophy. What does it mean that such signals can even be heard? It means that consciousness is not isolated from the cosmos, but is in dialogue with it. The human brain, wet with water itself, becomes an instrument tuned to the same frequencies as interstellar reservoirs. Thought becomes an extension of chemistry. Reflection, a continuation of molecules vibrating across time and space. In this light, human curiosity is not an accident, but a natural progression. Water, contemplating water, atoms rearranged into awareness, observing their own abundance scattered among the galaxies. But philosophy also cautions against hubris. The scale of discovery dwarfs the human measure. The reservoir around the quasar contains thousands of times more water than the entire Milky Way, and yet it remains inaccessible, uninhabitable, untouched. For all humanity's ability to measure, the reality is still beyond reach. Instruments can detect it, equations can describe it, but no hand can grasp it, no vessel can carry it. This is the recurring theme of cosmic exploration: knowledge without possession, understanding without control. Still, there is power in this. The history of thought is shaped not by what could be owned, but by what could be imagined. When Copernicus displaced Earth from the center, humanity gained not territory, but perspective. When Darwin revealed the kinship of species, humanity gained not dominion, but context. And when astronomers discovered cosmic water, humanity gained a new metaphor for belonging. The oceans of Earth became chapters in a much larger story, a story that extends backward to the birth of galaxies and outward to horizons not yet seen. From this vantage, water becomes more than life's requirement. It becomes life's possibility, repeated endlessly in conditions both hostile and benign. The molecules may never gather into oceans everywhere, may never cradle ecosystems or civilizations, but their presence ensures that the potential is woven into the structure of reality. The universe, then, is not barren but brimming with seeds, scattered across expanses where only time can decide which ones take root. Time itself complicates the reflection. The quasar's water is ancient, a relic from when the universe was less than 2 billion years old. To detect it now is to glimpse a memory of creation, preserved in light that has traveled across cosmic ages. This means that water, this simple, fragile molecule, was abundant almost as soon as the first galaxies ignited. Life on Earth arose only later, billions of years afterward, but the stage was already prepared. The cosmos was never a desert waiting to bloom. It was an ocean waiting to surface. This realization shifts the emotional weight of discovery. Humanity, in its brief existence, often imagines itself as late to the story, a fleeting afterthought on a fading planet. But the presence of ancient water suggests otherwise. The conditions for life, or at least the chemistry that supports it, were established early and pervasively. Humanity is not an exception, but a continuation. Its emergence is not an accident, but one of many possible verses in a cosmic song whose rhythm was set long before Earth cooled. And yet, the awareness of abundance does not erase fragility. On Earth, water cycles endlessly through evaporation, condensation, rainfall, and flow. It sustains forests, shapes weather, regulates climate, and nourishes every living cell. But its stability is precarious, dependent on balances that can be disrupted. To recognize water's cosmic ubiquity is to realize that Earth's oceans are not eternal, they are contingent, maintained by forces that could shift, vanish, or transform. This knowledge does not diminish wonder, it intensifies it. To live in a moment when oceans cover continents, when rivers sculpt landscapes, when clouds veil the sky, is to inhabit a fleeting harmony in a universe of extremes. Here lies the human paradox again, fragile yet significant. The same awareness that reveals impermanence also grants meaning. To drink from a spring, to watch rain fall, to swim in a tide ease, to partake in a miracle both ordinary and cosmic. It is to join molecules born in ancient stars, recycled through space, condensed on a small planet, and drawn into the cycle of life. Every glass of water is a history lesson, every droplet a relic of creation. This recognition touches the essence of philosophy, that existence is both gift and mystery, both measurable and ineffable. Science can quantify molecules, measure reservoirs, predict cycles, but it cannot answer why molecules should resonate with such symbolic weight, why life should arise from their dance, why consciousness should reflect upon them at all. These questions belong to another realm, where thought reaches beyond data into meaning. And there, water becomes more than matter, it becomes metaphor, memory, and mirror. In this sense, humanity's reflection on cosmic water is not separate from its oldest traditions, but an extension of them. Just as ancient poets saw rivers as boundaries between worlds, modern astronomers see reservoirs as boundaries between eras of cosmic history. Just as prophets saw floods as acts of renewal, scientists see interstellar clouds as nurseries of stars. The metaphors change, the language evolves, but the impulse remains the same: to find in water a bridge between the visible and the unseen, the present and the eternal. Thus, the story circles back to Earth. A planet shimmering with oceans is no longer a rarity, but a participant in a larger pattern. Its uniqueness lies not in possession, but in perception. Earth is not the only world with water, but it may be the only world, so far as known, where water has learned to reflect upon itself, to see its own image in the mirror of the cosmos. That reflection is both humbling and exalting, a reminder that meaning arises not from scarcity but from awareness. And so the reflection continues, flowing outward in questions that may never find answers. Is life scattered across the stars, waiting to be found? Or is humanity a lone droplet, suspended in the vastness? Is the abundance of water a promise of kinship or a reminder of isolation? These questions ripple like waves across the shore of thought, retreating, returning, never ceasing. The universe does not resolve them, but it provides the tide on which they move. In the end, perhaps the greatest gift of discovery is not certainty, but wonder. The knowledge that water flows invisibly across the universe does not diminish the oceans of Earth. It magnifies them. Each drop becomes a symbol, each wave a testament, each rainfall a chorus in a universal song. Humanity stands at the edge of that song, listening, reflecting, aware that the music began long before and will continue long after. Thus, water becomes the final metaphor, a timeless thread connecting past to future, matter to meaning, earth to cosmos. It is the substance of life, the mirror of thought, the memory of creation. And in every reflection upon it, humanity discovers not only the universe, but itself.